Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at first principles. So this formula here is called first principles. We actually saw it in a previous video. Remember what this formula doing is we're taking a curve and we're finding 2 points on the curve and the gradient of the line that joins those 2 points. That's what this is. This is just the 2-point formula for gradients, 2 points on the curve. But remember what we've seen in actually more than one video is that we need those 2 points on the curve to be close together so it gives a good approximation of the curve. And that's what this means here. The 2 points are so close together, we can't even tell them apart. Their distance is very close to 0. So we can use this formula to differentiate power functions. So a power function is something like this. So we're going to look at fx equals x to the power of 5. So what I'm going to do is I'm going to substitute into this formula. So the answer I get is called f dash x, also dy dx. Both of these represent the derivative of the function. That's what this calculates. We're going to calculate the derivative of this function here. The derivative of this function is another function that tells us what the gradient of this is at different points. In other words, it's the gradient of the tangent to this curve. So let's substitute this in. So f of x plus h is x plus h to the power of 5. So then I minus fx and divide by h. So we know how to expand this from last semester. So when I expand this, I just get this big expression here. So we've got f of x plus h, which is that, minus f of x, which is x to the power of 5 over h. And I should have put the limit there. We're taking the limit as h approaches 0. So what we're doing here is we're simplifying now. So x to the power of 5 minus x to the power of 5, they cancel out. All of these other terms have in them a h, so I can just divide by h. So 5x to the power of 4h divided by h, that just gives me 5x to the power of 4. This term divided by h, well, the h squared divided by h just leaves me with another h. I get 10x cubed h. And similarly, the next one is 10x squared h squared. The next one is 5x h cubed. And the last one, h to the power of 4. This is after dividing by h. So what I'm going to do now is take the limit as h approaches 0 of this function here. But if h approaches 0, this, and this, they all approach 0. If you times something by 0, you just get 0. So all of these will approach 0, and I'm just left with 5x to the power of 4. So if fx equals x to the power of 5, the derivative of that is 5x to the power of 4. So we're just going to practice this a few times, and you will notice a pattern with power functions. Move the power to the front, and then decrease the power by 1. So what exactly is this? Well, this tells us how to find the gradient of the tangent of this function, how to find the instantaneous rate of change, how much this is changing at a given point. So for example, when x equals 1, if I substitute 1 in here, I just get f dash of 1 is equal to 5 times 1, which is 5. So that means when x equals 1, this function here has a gradient of 5. So here the graph of y equals x to the power of 5. At the point where x equals 1 on this curve up here, I'm saying the gradient is 5. If I were to draw a tangent to that point, I'm going to draw a line that hits the curve just once and is going in the same direction of the curve. The gradient of this yellow line would be 5. So that's the instantaneous rate of change. That is how much the function is changing at one particular point. It will be changing a different amount. You'll get a different gradient up here at a different point. There'll be a different gradient over here. But this is a function, so we can substitute in any value of x and find the gradient of the red curve. It's just 5 times whatever x is to the power of 4. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.